Alright, so now we're going to talk about the line of best fit. And your learning target is I can determine a line of best fit for a set of linear data. Let's get going. So the line of best fit, that's your first blank here. The line of best fit is a straight line that comes as close to all points given in the data set. The process of finding the line of best fit is called linear regression. Okay, linear is that second blank. And a residual is the vertical distance between a data point and a line of best fit. All right, so let's pretty much just sum this up real quick. We have this data, and in order to find what the line of best fit is, it's kind of like a trend line. It's supposed to come as close to all of those points as possible. Okay, and we do this using a term called linear regression. You find the linear regression of a data set. Now, the residual is that distance between the line and each point that is given on a graph. Okay, let's do an example, and hopefully this will make a little more sense. So here in example 1, we're given a table, okay? And the table shows the average temperatures of several cities in the United States. We want to find an equation for a line of best fit. Okay, so I'm not going to go through each one of those cities and the latitudes and the average temperatures or anything like that. You can see the table, but what I'm going to do is I'm going to move this table down, or move the paper down a little bit, and we're going to try and find an equation for the line of best fit. And what you need to do, what you need to be able to do that is you need to have a calculator. So if you have a calculator out, or I want you to get a calculator if you have one near you, okay? So you might need to pause the video. So line of best fit, in order to do that, we're going to use our calculator. Let me back out of this. We're going to use our calculator and we're going to put that into our table. Now to put stuff into a table, you need to press the stat button. The stat button is right here at the bottom of your screen. It's 2 to the right from alpha, the green button. Press stat and you're going to click enter on edit. Okay, that's editing the table, and we're at this point right here. Now for list 1, the L1 right here, we're going to put in all of the latitudes. All of the latitudes on here, okay? So what we have here, I'm going to kind of move the screen a little bit. We've got 71.2, 62.1, 51.3, 41.9. If I could type right. So I want you to put these into the calculator just like I am doing, all the way down for list 1. Okay, and you should get to this point here. Now we're going to put in the average temperatures, this list right here, in list 2. Okay, in list 2. So we've got negative 12.7, negative 10.1, 10.4, 10.3, 13.8, 22.8, 22.8 again, 24.5, and 27.1. Okay, now we should see that these match up in the list 1, the number of list 1 things and number of list 2 things match up. And now in order to figure out what the linear regression is, what we're going to do is we're going to hit stat. And we're going to go over to the calculator button, okay? We're going to try and calculate what that linear regression is. Remember I said we want to calculate the linear regression. That's that 4th option under the calc section. Okay, you're going to press enter on that, and in order to do this you have to press which lists that we're talking about. So you have to press the list 1. You can see there's a blue little part right here that says L1. That means you have to hit second 1. Okay, so second and then press the number 1, and that'll give you L1. And then you do comma. This is to identifying the list we're talking about. List 2, which is second 2. Okay, and we get list 2. All we have to do then is press enter, and we get this this whole thing right here. Okay, remember linear lines, we use slope-intercept form, which is y equals mx. It uses a here plus b. All right, so now all we have to do is we have to plug this number in for a and this number in for b. And that's all we have to do here. So our line then, our line of best fit is y equals a negative 0.69. We'll just round it to negative 6.69. So y equals negative 0.69 x plus our b, which we see is 39.11 to round it a little bit. Okay, and we could use these little about symbols. That might be a little bit better to show that our line is a best fit is somewhere around there. Okay, the second part here, and I'm going to move the paper again, is to interpret the meaning of the slope and the y-intercept. Okay, the slope is that coefficient of x, right? It's that m, negative 0.69, and what that identifies is the temperature decreasing each degree of latitude that we go up. Okay, so you know latitude and longitude. Latitude is the horizontal lines on Earth, right? And the more north you get, the higher the latitude gets, right? Because Alaska, the top of this table, is much higher north of the equator than, you know, San Francisco or India or Senegal or Algeria, those type of things, right? So your slope then, the slope is the degree, slope is the degree increase in latitude one degree. The temperature decreases 0.69 degrees Celsius. Okay. Now the y-intercept, this is all talking about, right? The y-intercept we have at 39.11. That means at the equator, the average temperature is 39.11 degrees Celsius. Okay, and then to answer this last question here, it says the approximate latitude of Vancouver, Canada is 49.1 degrees north. Use your equation to predict Vancouver's average temperature. All we have to do then is put 49.1 in for x and solve. So we've got y equals negative 0.69 times 49.1 plus 39.11. Okay, and if we solve that, if we plug that in here, negative 0.69 times 49.1, negative 0.69 times 49.1, and then we're adding 39.11, is 5.23. And that is the average temperature in Vancouver then. All right, example 2, the last example here. It says the data is graphed along with two lines of fit. For each line, find the sum of the squares of the residuals. Okay, remember residuals is the distance a number or a point is from the line of best fit, right? And then we want to know which is a better fit. So the first thing we need to do, looking at this graph here, we're given 4 points and 2 lines. This first line, we see the slope is rise 1, run 2, which means it is 1/2 x plus our y-intercept is at 3. And our red line, we see we have the same slope, y equals 1/2 x, except our y-intercept is 2, 1/2 x plus 2. So all we have to do is we have to figure out what the distance is from a point to the line. Okay, let's work with the red line first. And we see that the red line, that's a distance of 3 units. That's a distance of 1 unit, 2 units, and then finally 1 unit. Okay, the distance for the red line. Okay, now the blue line. So what we're doing here is we're trying to see which line is a better fit. The blue line goes up 2 units. It goes down 2 units, up 1 unit, and finally one more is down 2 units. So we want to see which line is going to work better for this scenario here, for these points on the graph. Which line is a better fit? And we can do that by using the square of the residuals. Okay, the residuals is what we just found, the distance a line is from a point. Okay, so I'm going to move this down a little bit so we can do that. We're going to work with our red line first. Okay, and we see that the distance that the red line was from the first point was 3 units. So we're going to square that and add to the distance it was from the second one, squared. Add that to the distance it was from the third one, which was 2 units squared. You guys can see we've got 2 units squared, and then the last one was 1 unit. Okay, and we just have to find the sum of what those residuals are squared, the square of the residuals, right? 3 squared is 9, plus 1 squared is 1, 2 squared is 4, and we add all those up together. 9 plus 1 is 10, plus 4 plus 1 is 15. Okay, so the sum of the residuals for the red line is 15. Now we do the same exact thing for the blue line. We see this first one goes up 2, so 2 squared, plus 2 squared again, plus 1 squared, plus 2 squared. Okay, 2 squared is 4, plus 4, plus 1, plus 4, and we see that's a total of 13. Okay, and because the sum of the residuals is lower for the blue line, we can say that y equals 1/2 x plus 3. That's that blue line that we're talking about. Let me move this down. That's the blue line. y equals 1/2 x plus 3 is a better line of best fit. Okay, so the residual helps us identify which line would be a better line of fit by finding the sum of those squares.